So one of the visions that Herbert Stoddard actually had for these plots back in 1960 is that people would study the effects of fire on soils. And so we have taken advantage of that by doing nutrient tests and soil carbon tests on these different plots. And some people are concerned about fire because they think it might be depleting the soil of nutrients, especially nitrogen is a concern. We found that nitrogen is pretty much the same between the 1, the 2, the 3-year plot, and even the unburned plot. And so we're not exactly sure why that is, but we do know that fire does promote nitrogen-fixing plants, especially the legumes or the pea plants that actually fix nitrogen from the atmosphere and put it back in the soil, whereas you don't have those plants where you keep fire out and it just becomes a closed canopy hardwood forest. So it seems to kind of make up for it, and nitrogen hasn't really been a problem. Whenever there's a fire, it actually replenishes the mineral nutrients like magnesium and phosphorus and sodium and potassium. And there's actually kind of a bump or an increase in those nutrients after a fire, and then it kind of settles down after a little while. So fire is actually good for those nutrients. There's been some concerns about soil carbon sequestration too. There's at least the possibility in the future of people having carbon credits for their land. So there might be concern, well, if I start burning, is it going to deplete the carbon from the soil and I may not get as much credit for my property? But interestingly too, we found out from these plots that if you take fire out of the plot and it becomes a closed canopy hardwood forest, the soil carbon actually decreases instead of increasing. And there's been a number of studies that show that in pine communities like this, and it may have something to do with the pines, we're not really sure, but frequent fire actually increases soil carbon over time. We're not sure exactly why. It might have to do with the fact that the fire slows down the microbes in the soil that decompose the soil matter, and so it decomposes more slowly, and so it spends more time in the soil. It seems to be one thing going on. Also, as you can see here in the 1-year plot, that frequent fire promotes fine-rooted species like grasses that have higher fine root turnover. So it's a lot of the roots are dying more often each year and being decomposed into the soil that allows that organic matter and that total carbon to stay in the soil. It could also be because when stuff gets charred and goes into the soil, it's harder for the microbes to chew on, and so it stays in the soil longer. So all of these, any or all of the above may be the mechanism by which fire actually increases soil carbon. But it's important for people to understand that if you're burning, it's not a big concern about soil. In fact, it seems to be important for soil health. Another concern that people sometimes have is soil erosion. But we found from doing some models and from some other studies that doesn't seem to be a big concern, at least in the relatively low topography like we have here in northern Florida, where it's hilly but not super steep slopes. When we burn, because the vegetation is perennial and the roots are still there, you're not really killing the whole plant and they just resprout again. The roots are never taken away, and so you never lose that soil stability. And so even though these areas are frequently burned and the soil is exposed for a short period of time, it's a pretty short period of time before those plants are resprouting again and breaking the impact of rainfall as it hits the soil, decreasing soil erosion, splash erosion, and also preventing water from running off very quickly over the land. Part of that's because of transpiration too. These plants are pumping so much water out of the ground that they find that in the southeast, especially in the warmer months, the water doesn't stay in the soil very long before it's transpired back up into the air again. And prescribed burning does a good job of keeping this surface vegetation that has roots close to the soil, taking that water out of the soil and back up into the air before it can run off very far. So for all those reasons, frequent fire does seem to be good for hydrological cycles. It tends to promote less soil runoff. Also, pine trees and not having a dense canopy cover is actually less transpiration for deeper water. And so once the water gets past that zone of fine roots in the surface vegetation, it has a better chance of going down into the aquifer and helping to replenish rivers and lakes. Whereas if you have something like a dense pine plantation or just an unmanaged closed canopy hardwood forest, those trees are really pumping a lot of water out from those deeper soil horizons. So, so on the balance, these frequently burned communities are a nice balance between preventing a lot of runoff from going over the soil, taking a lot of sediment with it and going straight into your water bodies, which you don't want, but then also allowing that kind of deep percolation that helps replenish water bodies through that nice, clean, slowly trickling water like is really more desirable. Whereas a closed canopy hardwood forest, like what's more common in the South, doesn't allow that water to get back into those water bodies, if that makes sense.